Hello, everyone. Thanks for joining our webinar here. I'm excited to be with you and show off some Python things, some database things, and just talk about database performance. So thanks for coming, whatever time of day or evening it is for you. So first of all, a little bit about me. I've been doing software development for over a decade, but it feels like so much longer sometimes. And my specialty lately has been databases, database performance. I just came out of a job or last year, sort of ended a job at IBM where we did managed database services, and I work for Redis Labs now, the Redis company. This is a web course for Python developers. How to use Redis is what I've been working on lately. So if you're interested, if you like this webinar, come and join us here at Redis University and take my course. It's starting soon. That's a quick pitch for my employer. And now I also wrote a book. It's a lot of the content that's in this talk is from my book. So if you're interested, check it out. But you're not here to talk about my book or even a course that I made. You want to learn about database performance. So let us dive in. Today, I'm going to be working through some performance problems and looking at some tools that Django gives you for database performance, and also just database tools that we get from the Postgres database. So to do that, the context that we'll do that in is a Django project called Quest. And you can see I'm in PyCharm over here, and I've got Quest open. It's got a number of little apps in it that we'll look at. The app that we'll spend the most time on within this Django project is analytics. So as you can imagine, analytics generates a lot of data, and therefore, by nature of generating data, it probably creates some performance problems. So we'll take a look at that, and that's where we'll spend most of our time. Like I said, we're going to use Postgres, and there will also be a section here on caching and going beyond caching with Redis to speed up other stuff in our app. All right, so what are the main topics we're going to talk about? Number one, I'm in PyCharm's Markdown view, so I'm just going to switch to looking at the preview since it'll make all the links clickable, and that'll be nice. But number one is querying. So we're going to talk about a few really core topics for getting better speed when you're doing queries against the database. And we're also going to talk about indexing. So indexing will sort of attack the problem from behind enemy lines, and you will be adding some stuff to the database side that speeds things up, speeds up queries. And then we'll also look at some advanced uses of Redis, or some things you might not have thought about using Redis for, as well as doing some caching with Redis. Sometimes when all else fails, you just have to cache, right? So we'll look at sort of how that works, but also some sort of advanced stuff down here. I don't want to spoil it. So let's get started with querying. So let's take a look at the app, right? There's a front end. This is, not it. This is the front end for the app. It's called Quest, right? And when you log in, you get this view. Now we're going to call this an LMS, a learning management system, because it helps you manage stuff that you want to learn. If you're familiar with JavaScript frameworks, you might notice this looks familiar. It is the To-Do app from To-Do MVC that walks you through building a to-do in different JavaScript frameworks. This one's in React. And as you can see, we put it to use here to manage our learning tasks for this goal. We want to learn more about the Django ORM. We could do some better rendering here to be faster, but we're going to talk about backend performance right now. So this is what we're talking about, right? This is the app. So as people click on things and complete tasks, they're generating analytics. They may not know it, but it is happening. And we also have a page in the app that shows the analytics data that they're generating. It's at this URL. Or I mean, it should be, but something seems to be wrong. It's not answering my request. So let's take a look at that. Why don't we check out the view itself, right? Now, Django debug toolbar could help us if the view could load. And we might also look at the slow query log in Postgres, but we kind of know where the problem is. We're looking at this particular problem. This page isn't loading. We know the app is up because we can see the logs. I use Docker for this setup. So you're gonna see a bunch of commands flash in the console, and it looks like the app is up, and you might or might not be able to hear the fan spinning on my computer. So we know something's going on. Let's check out the URLs for the analytics app. So you can see we've got a number of, maybe you can see, maybe you can't. Let's make this bigger. So we've got a number of URLs for this app, and this is the one we're looking at. It's called All Events. A little bit of a foreboding name. Let's check it out. Okay. All right, so it renders all the events, and that's it. Oh, wait a minute, all the events. Wait, what? That's probably not gonna work. There's a lot of events in there. You know, there could be millions of events. So probably that's just never gonna load, right? So a really basic performance tip, but something that not everybody knows about, and also something that has a lot of nuances that we'll talk about, is pagination. There are other things you should know, but pagination is really core, right? So the first type of pagination that you should learn about is called offset pagination. Let's take a look at what that would look like. So we want to basically get all the events and render them in a table, right? So we were trying to do that just by getting all the events at once. The database is going to try and give us, you know, hundreds of thousands or millions, and we're going to try, Django's going to try to render that. That's not going to work. So let's do offset pagination. Let's look at how that looks in Django. First of all, we'll get back to this. We also added some select related in here. This is some magic that you need to know about. It's not the core of this talk. Right now, we're going to talk about this, Paginator. So Django gives you a nice tool called Paginator to automatically keep track of separating out a large query set into pages, right? And when you use it, it's got this nice little API, get page. And that means that you can have your URLs just pass in a page number that Paginator should find in the query set. This is the query set, right? All the events. And then we render just the page. And you give it a number of how many items you want on each page. We're going to do 10. So let's see what this looks like when we use this URL. All right, so it's a lot better, right? We actually worked. I think we've killed the database with our other query that's probably still executing. So, but it's still, now we can actually complete this job. We can complete the task. And that's what we want, right? We want a quick performance hack that makes this work. Pagination is always going to be that thing that makes a slow page with a lot of data work again. So you should know how to use pagination, right? And that's how you do it in Django with offset pagination. So interesting thing though, side note, right? What if we just took this out? Because we have this, we added this from the last version of this code. What if we just took it out and ran this page again? The app has to reload after you change code, right? So it reloads, and then we do this again. All right, so now we're on page 3. So check this out, right? What is going on here? There's a lot of queries. And the reason there's a lot of queries, even though we're only talking about 10 items, is that if you look at what this template does, maybe we thought we were just dealing with events here, and that's, you know, it's gonna be 10 queries, sure, and maybe a couple extra. But at the actual template, for each event, it's also rendering some related data. It's getting the user's username, it's going into their user profile and the account to get the account name. So it's got to make a lot of extra queries, and you can see how that really blows up the number of queries required for this relatively simple view just by default if we don't do anything. So when you add select related, that's really what you want to know about, right? That you want to remember select related. Okay, I've got a lot of queries, they're related data. And then if you add select related strategically, you can drop the number of queries down dramatically. So now we're back down to 3. All right, that was just a side note on select related because, you know, select related, if you do any Django, you'll come across this relatively quickly. But pagination has some more nuances that I'm going to talk about now. we looked at offset pagination. So the way that offset pagination works and why it's called offset pagination is if you look at these queries, this query that's doing for these items, so it works by saying, okay, in the total result set for all the queries, right? Start at the 20th item and then give me 10. So start at an offset and give me a limit or the maximum number you should get back. So that becomes a problem in some cases, right? It becomes a problem if we go to Twitter and you're actually building pagination. I hope this isn't a trigger warning for you, but there might be some political comments in Twitter. I don't know if you've used Twitter, but I try, but it's hard to filter them all out. So I'm just scrolling down and I can scroll as long as I want, right? And it keeps paginating. Oh gosh, I don't want to see that. Right, so it keeps paginating. And what's happening behind the scenes is that at each of those offsets, right, at each page of results, the database still has to go through all those queries, right? If we go back to our app and look, like let's say it's page 1000. In this database, that's pretty good, pretty fast, but you know, depending on your database server, your app, how much data is in it, and how deep the pagination is. And also, I don't know if you heard, but my computer just started going crazy because the database has to load all the data up until this point, up until the offset specified, in order to satisfy this query. So deep pagination is fundamentally broken with offset pagination, and oftentimes you just have to turn it off. You can't let people paginate deeply. So when you have a large database set, you want to use an advanced technique. It's called key set or seek pagination. I call it key set pagination. And the way that key set pagination works is using cursors, right? So it kind of works like this. So you wouldn't have a page number. You would just have some kind of opaque cursor. It's usually base64 encoded value, and you send the cursor to the back end. The cursor looks up the position in the result set to start with, and then asks for the next items. And it may be hard to visualize what that looks like, but there it is. I don't have time to really get deeply into it. However, if you want to read more about this, I do have a book, obviously, that I've been selling. You can read about it in my book. There's a whole section on it with some example code. But also, if you just want to check this out with Django REST framework, the API framework, has a cursor pagination class that you can use, and it does this. It does key set pagination. So go and read how this thing works, and you can drop it in and start using it right now in your APIs if you use Django REST framework. So check that out. That's my advanced magic of pagination. Read all about it, learn about it, know it. It'll save your life someday. Okay, now let's talk about annotations, which is part of the aggregations framework in Django. And let's talk about what an annotation is. First, we'll start off with example code, sort of help us visualize what we're going to be annotating here. Let's get back into the app and go to, what was that, dashboard. Okay, so let's imagine that we have this custom Django backend, right? With Django admin thing. We have a Django admin site, we've done some customization, so we have a custom dashboard. And if you go to this dashboard, you'll get sort of this summarization of the current state of things in this app. And the metric we really care about is how many tasks people are completing. We have some work to do, but imagine it's a large number, right? So we're going to say for each goal, count up the number of completed tasks. And what I mean by that is times that a user has actually clicked or checked off that item. So it could be a lot. So we want to do some math, right? We need to do some math to generate this. And it turns out that there's a lot of different ways we can do that math, and they matter a great deal, the differences. So let's get in here and look at this. Let's see, we're not here, we're in the admin. So if you've never used, or if you've never customized deeply the Django admin, there's kind of a lot of stuff you can do. And one of the cool things you can do is you can just inject your own views at whatever URL you want, and then sort of, as you kind of saw, reuse the Chrome for the admin, and it makes it look like whatever the rest of the admin looks like for your users. So what we're going to do is we've injected some of these views And this is the one we're gonna look at first. As you can see, we're at goal dashboard Python, right? So if we look at this, it's in the same file. We're gonna use PyCharm's excellent navigation though to get there. So goals dashboard view Py, right? So first of all, warning, you typically don't do this. You don't wanna do this unless you have to. It's inefficient to do this if you're counting numbers in a database, because the database can do it for you. But let's take a look and see if you were to try to count up the number of completed tasks with Python, what would that look like? All right, so we have this model, it's task status, and it records when a user starts and completes one of these tasks. And the task was something like, read about annotations, right? So we're gonna loop over all the goals to build that table. Already your spidey sense should be tingling because we didn't use pagination, but whatever, just ignore that for now. What we wanna focus on is we're looping over all the goals to get all the times somebody has completed a task in the goal. And then we pull the tasks out, which are related to the task status model. And we build this thing, right? We build a number. Then we're gonna set a new attribute on the object itself using just Python's dynamism, right? We can put values on an object instance. We're gonna put completed tasks. It's gonna be the number of completed tasks. As you can see, we get the numbers out, right? We get it this way. We also need to sort this, and we're gonna grab the top 10. We're not paginating, we're just gonna do all the work and then discard everything and grab the top 10. Then it gets rendered, we get this table. So why wouldn't you do this? Or why might this be a bad idea? Let's hop over here and look at this number. So this is a kind of a high number for just a view. It means the CPU is doing a lot of work. And as the data grows in this database, the amount of work that Python's doing is gonna grow as well. And you don't want that, right? That's not good. That's gonna be its own performance problem. So you wanna be able to move that work to the database, and you can using annotations. Let's take a look at our annotations-based page, right? It's the same page, but we use annotations instead. And you can see that we have a lot less CPU work. We also managed to use less queries. Let's see how we did it. Now, conveniently, this method is located right below us where we were at. We're gonna look at this, goals dashboard view SQL. And this gets into some kind of deep ORM stuff that you can do with Python's ORM tools. So here, we're just gonna run a query. Let's take a look at the query. It might even be easier to visualize this. If you look at this query, it's gonna be a giant query, but you can see we're selecting a bunch of data. We're coalescing the count, darn. Let's get back to that. We're coalescing the count of these items. So we do this, all of this work we can do in SQL. We can do the exact same stuff we were doing in Python as a sub query with SQL. And you can do subqueries in the Django ORM because it gives you this object to do it. So here we do this subquery. Let's start from the outside though, from the annotation. So here's where we actually annotate these goals. And annotating is a lot like setting an attribute on something, except you get to run a function. So we're running this, essentially we're running the subquery, and coalesce is really just helping us avoid null values or nones coming into our result set. So we get a nice clean 0 if there were none. As you can see, we did have a 0 or 2, and we also got our numbers. All right, so obviously you already saw this is more performant, it's faster. Let's get back to the SQL version. I just changed back to the SQL version. It's faster, it's less SQL queries, so that's great. That's what the power of annotations are, right? That's the power of annotations. If you think about annotations versus aggregations, annotations go add something to each result in a query, like the number of completed tasks. Aggregations reduce a query set down to particular numbers. We're not going to talk about aggregations much, but they work with the same kind of, the same way, basically, or very similar way. Okay, that was annotations, a very important tool. Let's check the time. Okay, good. Well, okay, let's speed it up. All right, so that was annotations. And let's move on to really one of your secret weapons, for database performance, definitely. Like caching is a secret weapon, materialized views are a secret weapon that you should know about. And I don't see this a lot in a lot of Django projects I use. So this is something you want to put a feather in your cap with. So let's just sort of break it down, right? It sounds kind of mysterious if you've never heard of this before, but a materialized view is basically like caching in the database. Okay, so it runs a query, you define a query that should run, and then you basically get to look at the results indefinitely until you refresh it. So that may, what does that even mean? Let's look at it. Let's go to the materialized form of this dashboard. I get sick of looking at this dashboard, I tell you. Okay, so it's the same dashboard, but now we're using some other deeper magic. Let's look at the magic. Where is that magic? Oh yeah, there's nothing to it, right? So, oh, that's interesting. Oh, there's nothing to it. I mean, there's really nothing to it at all, right? We're just rendering this page and we just give it this model called goal summary. That's interesting. Well, what is goal summary? Let's take a look. I'm gonna jump to it with PyCharm's tools here. So yeah, goal summary. It's just a model, right? But you'll notice something interesting about it, right? So we'll come back to this in a second. So this goal summary, it keeps track of a goal, particular goal, the number of completed tasks at a point in time when this was run, right? When the query was run, we get this data. So this is when you're using a materialized view in Django, you can access it through a model. Okay, and it's a little bit different from other models. It's unmanaged. So you just throw this in here because this isn't really a table. Most models are backed by tables in Django. This is a model that's not backed by a table. It's backed by a view of data at a particular time. So it still might be unclear, like where is this data coming from? So let's take a look at two things. So first of all, if you're gonna build your own materialized view, you create a model like this, and then you create a migration. So even though it's unmanaged, Django creates the migration to make it aware of this model. And let's take a look at that migration. It looks something like this. So here we have, the create model migration operation that Django added. And then we added, to make a materialized view, we add this thing, this extra thing. Okay, ignore everything else. This is the important part. And this should answer some of those questions, those mysterious questions. Where is this data coming from? It's coming from this query, right? This ultimately is what actually produces data for a materialized view. So we have a query. It looks a lot like that other query that we were just investigating for our subquery. That's because I just copied and pasted the code that our ORM generated for the dashboard. And I put it in a materialized view. So what does this do? What does this even do? It's just a SQL query. So what happens is the first time we run this migration, it creates the view with the data at the point in time that it ran. And the date you get, if you're looking in, back in your models file, this comes from the query, comes from the query itself. It selects the date, the current date. So we get the date that this query ran at. All right. Now, so that's great. We ran the migration the first time. We created the data. So what about when you want to update it, right? Is it just going to always look like this? And that's it? Yeah, it is always going to look like that unless you do something else. And that is that you need to refresh the query, so refresh the materialized view. So in this project's case, we put it in a management command. So you can see it's very simple. Once you've defined the query, you don't redefine the query. You just call refresh materialized view concurrently. We add that concurrently because Postgres can do this in the background without blocking. So we refresh the materialized view, and that's going to put new data in the view, right? So that's a materialized view. So you need something to refresh it. You can put this could be, a celery task or something like that. We have a management command. You have a model to view the data. It's basically read only because you're just viewing calculated data. And then you can use it. You can just use it as a normal model. You can use it as a normal model inside of a template, right? We're calling it a summary. All right. that concludes querying. Unfortunately, it's also the day the city decided to destroy the sidewalk outside, so you might hear some background noise. I apologize. So that is querying. Let's move on to indexing. So indexing is, like I said, you're attacking the problem from the back end, the deeper back end. We want to attack it from the database side. So we're going to create some indexes, but we're not just going to create any old indexes. We're going to create some advanced indexes. The first thing we're going to do is create covering indexes, and then we'll look at partial indexes and why you might choose to do that. So what is a covering index? Do you know? If you don't know, I'm so glad that you don't know, because otherwise this is going to be boring. But if you don't know what a covering index is, it means an index that can service a query by itself without using the database table. So if you imagine the database, right? The database, let's just start looking at a console of SQL queries here. So here's a query we're going to look at. So the database, to service this query, the database, you know, without any indexes, the database has to do a sequential scan of the table, and that means it needs to look on disk for some of this data, probably, and that's going to be slow because you're going to have to go on disk, yada yada yada. So the point is, the reason you use an index is it's a separate data structure that's faster. It's called a B tree, typically. It's a B tree index, and it's designed for faster searching to find where things are on disk, or typically, right? So even better though, right? So in a typical index situation, what happens is the database uses the index to find the items on disk, typically. With a covering index, it doesn't need to go on disk, so everything is much faster. We'll even look at this a little bit more and what that means. But so you do this for speed. You do this because it's faster than a normal index. So let's look at what it looks like to add an index. Looks like it's hitting my. Let's look at what it looks like to add an index, and we'll just look at a normal index. Clearly, I need to change my keyboard shortcuts. Okay, so if you want to add an index with Django, it's pretty simple. You pop up in the model, and you can add an index into the indexes list, right? And here we have, this is a basic index. I'm going to show you this deeper magic here in a minute. Don't be scared. But it's a normal index, and once you do that, you create a migration. You do make migrations like this. Make migrations, yada yada, and then it creates a migration. Let's see which one we want to look at. Let's see. This one. Okay, yeah. So this is the migration I created for that index. You can just automatically, you know, when you do make migrations, you get an index migration, but you can also use this new feature of Django 3, which you should definitely know about if you're using Postgres. It's add index concurrently. So normally when you add an index in Postgres, the table gets blocked. Postgres blocks table, and that can slow things down. It can be a big problem. So you want to do it concurrently, and you now have a simple option to do that. So this is what it looks like. So you run this migration, you get an index, and then for the right queries, it'll be a ring index. What does the right query mean though? Let's take a look at this. So PyCharm also has this cool thing. You can do an explain analyze. I think it looks like this. So we want to you do it on the query. And as you can see, this is completing the statements, right? So that's not what it looks like. This is what it looks like. So it breaks down some of these numbers that we're going to get in this query plan into this table. My eyes are a little small for this, so I'm going to run it and show you what it looks like just as text, but know that there's a better option probably. But if you're really familiar with this already, or you want to become familiar with how this looks, this is what the actual output looks like from Postgres. Let's see, hold on a second. When you're doing any queries with Postgres, doing any performance stuff, you want to vacuum the database first. Whenever, like if you make a change, because sometimes you just get weird stuff. Let's see. I'm saying because we're not actually getting an index scan, so let me migrate this analytics app to make sure we have all the indexes actually in there. Let's do a vacuum, and then actually let's confirm with PyCharm's tools. So we just did a vacuum. What vacuuming does is it tells Postgres to reevaluate some of its statistics. So like its statistics are the way it's really advanced query planner figures things out. So I'm going to open up the database panel in PyCharm and look at this table, the analytics events table, and let's see if we can find our index. All right, here's an index. It's basically the index that we're using here. It's the index we're about to look at, and that's fine. So this is where we confirm, okay, we do have an index. I think I had dropped it and just re-added it by running migrate. So now, if you notice, it was doing sequential scan. That's not what I want to show you. I want to show you this. Okay. So this is what it looks like if you're doing it right? If you got it right, this is what it looks like. We have a query that, let's look at this query, right? So this query selected the name, and the index that it used has the name stored in the index. So ignore the fact that we already know the name, but the whole point is, right, when you select data that's in the index, in this case, we have an index on name, then all the information you need for this query is in the index itself, and you get this back. So the important thing is index only scan. So it was able to satisfy our query directly from the index, and it makes for a relatively quick query, depending on how much data you have. It's faster than a sequential scan typically. So index only scans, or as they are known, covering indexes, are your best bet for the fastest index for a particular query, usually. There are always trade-offs, right? So there's no silver bullet. Covering indexes are not a silver bullet. What happens is the more queries, the more indexes you have, and the more covering indexes you set up for all your queries, the slower that writing data becomes. Because when Postgres or most relational databases write to an index, when they write something into a new table, they write to the index at the same time. So that's something you need to be aware of, your write speed. So we saw a covering index where we were able to satisfy a query directly from the index. Let's quickly look at something else, a little bit different. It's called a partial index. So I'm just kind of going a mile a minute to try to get you all the information that I want you to learn in this webinar, right? Because this is the kind of stuff that I think is just really good to know for your career. If you're a junior developer, if you are a intermediate developer and you're wondering where to go next with your career, I highly recommend databases and database performance as a specialization. You just want to be that person. You want to be that person they call when it's just not working or it's slow. It's a great place to be in your career. So think about that while you ponder what a partial index might be. Okay, partial indexes. Okay, we've already seen how to define an index in Django. And now we're going to look at how to define an index that only indexes some things, right? Only some things go in the index. Because normally an index stores all of a thing, all of a certain thing. This is going to store all the names. And then if we're querying for names, we're comparing names, we get to use the index. But this index stores all the names unless this is an excludes query using the queue object. If you're not familiar with queue objects, look them up. They're really convenient, and they come up in advanced SQL ORM stuff in Django because it allows you to break apart a condition of a query and pass it around. Here we're able to pass this particular condition if this analytics event is not named goal viewed. In other words, everything but goal viewed events go in this index. So that seems weird. Why would you do that, right? Why would you do that? It's because sometimes you can get a table that's full or has a lot of one particular thing, like goal viewed events. So when you have that and you're using an index that just indexes everything like this, it's a big index and it's not as efficient. Especially if it's not as efficient, especially because typically a query planner is not going to even use an index when it's got 500,000 items that your query brought back, right? Because it ends up having to do a sequential scan for large results a lot anyway. So and to show you what I mean, let's kind of look at this. So let's run a query for all of the goal viewed index events, right? So we got a sequential scan, and we do that because that index we were just looking at doesn't even include them in the index, first of all. So let's say we migrated. I actually just had this as the current state of the database. There's an index. It doesn't index this particular item, and it takes a long time. Now, spoiler alert, it actually takes a long time anyway, even if you have this stuff in the index, because there's too many items. There's this many items. There's way too many items that this query is dealing with. So that's an interesting thing to know about, right? So we don't need this data in the index. This is the point. We don't need this data in the index. It doesn't help us anyway, and our indexing is going to take less space. It's going to take less space and take less time without those items. So you can see when we query for something else that's not goal viewed, we're using the index, and we're back to getting to use an index-only scan like we were looking at before. So things that are in the index, all the stuff except for the stuff that's taking up all the space is really fast. And the stuff that would be slow anyway is still going to be slow either way. But this way we save time and space. Okay, let's look back to our outline. That was a whirlwind tour of indexing, and let's look at what do you do when the poop hits the fan, right? Sometimes it's going to be you create a materialized view. There's some query that is just crushing everything, and you can't make it available in a web request. What do you do? Well, materialized views, one of your #1 picks. But let's say even that whatever, it's that query itself is causing problems. It's backing up the task queue that runs that task, or you can imagine some different scenarios, right? And your indexes didn't help. You did all the indexing, but sometimes it doesn't work. Your indexes don't help, and you are backed into a corner, and that is when you can turn to your handy Swiss Army knife, which is Redis. And there's actually Redis, if you haven't used it or you've only used it for caching, there's many powerful features that Redis has that you can use in a lot of different contexts in Django and other web apps. So don't think this is just only Swiss Army knife feature it has, but this is one of them, right? So when you're backed into a corner, you got to reach for caching sometimes, and it's really easy to set up in Django. I'm going to show you how to set it up with Redis, because something that can be nice is that if you're using Redis already, right? If you're already using it for something, it's really easy to use it for something else and sort of use some of its other features. And I'll show you sort of how that works. But okay, so if you just want to set up caching, whether you're using Redis or not, you could be using memcache or whatever, but this is how you do it no matter what. So you go in, you add this caches setting, and you point it somewhere, right? And here we're going to point it at our Redis URL. It's a little more complicated for this setup because I use Docker, but I also want this to work if I don't use Docker. So anyway, but it's the same thing, right? We have a URL pointing at this, whatever this data store is that we're going to use for caching. This is an interesting, cool thing we'll get to in a second. So that's about it. So you configure the cache and then you're done. Now you have a couple more steps depending on how you want to use the cache. So the first thing you could do is, something you could use the, blowtorch approach, I guess, is you can just cache everything. You can add this caching middleware, and I don't do that usually, but it's definitely an option you have. You can just cache the result of all the URLs essentially in your caching system, and you can just turn it on and that just happens automatically. But there's something a little more interesting you can do with caching, of course. You can kind of go lower level, right? And you can go lower level and sort of cache things, cache whatever you want, essentially, right? So we're going to look at what that looks like. Let's go back to the admin once more. Let us return into the fray again, and now we'll look at a version of the admin dashboard that uses Redis. And this is what it looks like to manipulate the cache, kind of manually. You import the cache, so that's all configured for you. and then you, in our case, we're going to use a key. So the way that Redis works is when you store a value, you store it under a key. Now, the value can be a lot of different things. There's a ton of different data structures that Redis has. It's kind of like a data structure server. In this case, we're going to store a big string. And you can see kind of, if you're using Redis, this is my pro tip that I want you to walk away from. If you walk away with nothing about Redis, just walk away with this. If you're using Redis, put your keys in the same place. Put them all in the same place. It makes refactoring a lot easier. You know, if I just want to rename this, I can use, you know, I can use this, where is it? This new feature, update usages to reflect signature change. And then, you know, it's just going to do the rename for me if I'm using PyCharm or whatever. I can use whatever I want. And I just have to rename the function, and I can find this a lot easier than a string typically. But anyway, so walk away with nothing else. Just put your keys in the same place. But let's get back to what this actually does. It's very simple, right? So we have a key. This is where we store the dashboard, cached, the cache stuff of the dashboard. Whenever we get a request for the dashboard view, we're going to try to get the thing from the key. We're going to try and get the previously built HTML, let's say, for this dashboard from the key. And if it's not there, we're going to use the other, we're going to just be lazy and use the other code I already wrote to generate this. You can imagine maybe this is just a different function that generates the result, whatever you want, basically. But here we're just doing this, right? So we generate what we want, then we put it in the cache, and we give it a timeout. So Redis will expire the key after an hour, at which point we'll come back through this loop the next time somebody comes here and we'll regenerate. But otherwise, we're just always going to get the item from the cache and return it immediately. So you can see we start to get better speed here. Like these queries, you know, everything is getting a lot faster. And that's kind of where what you get with caching. Everything, it's the way to go faster. Obviously, that's what we're doing with all this stuff, but it is one way to go very fast. All right, so that's manual caching. We also looked at middleware caching. Let's go back to my outline so that I don't get off track and take a look at what's next. Session storage, right? So there's lots of stuff that you store in a database, right? You store a lot of things in the database, and you're always hitting the database doing writes and stuff like that, writing new data and stuff like that. So sometimes a performance tip that you could do is basically move some of that work out of the database. Sometimes you move work to the database, right? As we discovered looking at our calculations, we moved from Python into the database with annotations. But sometimes it's stuff that you just want to move out. And one thing you can do is just use Redis, right? You can use Redis to store something like sessions. Redis is a good fit for session storage because unlike what you might have heard, and my double escape, unlike what you might have heard, right? Redis persists to disk. It doesn't have to, like, and everything does need to be able to fit into memory, but it has a number of persistence options. So that means that you can store sessions in Redis, and if Redis, you know, you need to restart Redis, then the sessions will still be there, and it's just like a normal database in that way. So what do we get from this? This is faster. It's something that you can move to Redis relatively easily, right? And so after that, when anybody logs in, then their session is going to go into Redis, and that's a win. That's a performance win. That's an easy performance win as well. So let's take a look at something else you can do with Redis, or even, you know, I guess we could just look at Redis. See. Yeah, there you go. So I logged in. This is, you know, if you're like, what is a session store? What does that even mean? What happens is when I log into my website, Django stores a session, and that's part of, you know, our authenticating and stuff. And now it's as a key in Redis. And I mean, what does this even look like? Let's find out. Right? Cool. Okay. So there's some stuff, lots of stuff. Great. Yeah. So that's what's stored in there for my session. So one more thing I want to show you about Redis, because this is actually kind of interesting. I'm just checking the time, make sure I'm on track. I want to leave time for questions, but I also want to show you this cool thing, this one cool thing. So let's look at this one cool thing with Redis. What else can we do with Redis? Well, if you know that Redis can store data, I mean, Redis can store data. If you know that Redis can persist disk, it doesn't mean that it's working like Postgres, where it's like storing things in disk and swapping things out in and out of memory, storing everything in memory, which makes it super fast, and it also is storing them to disk as well for recovery when you restart it. But anyway, if you know that that's the case, what else can we store in Redis, right, to speed this up? And this is, part of your job as doing performance tuning is to look at things that you can make go faster. So let's say you have an API with Django REST framework and it uses token authentication. So clients are going to hit the API a lot, and every time they do, they include a token for authentication. Now, your first try at this, right, you just sort it in the database. That means that every time API clients are hitting the API, you're having to go to the database to look up these tokens. So that's something we could move to Redis, right? And how you do it is, we're just gonna, well, basically it's kind of advanced, right? But with Django REST framework, you can have a number of authentication backends. These are like, like everything else in Django, it's kind of a swappable class, right? So we can just add our own thing. Why don't we just add something that stores the tokens or looks up the tokens in Redis? So that's what we're gonna do, right? So we're gonna, we add it into this setting. And then after we add that, that means that just by, without us having to do anything else, this class gets called. And it's a very kind of narrow API. We get this method gets called. So when an API client hits us, we get this authenticate method that's called on our class. We get a token from the request. We built this, right? We get this token because we look at the header and we split it out and get the token value. Now, in our case, we're not doing any special tokens like JSON Web Tokens or anything. This is going to be just for demo purposes, simple token. And our simple token is that we have a key in Redis, and it's a hash that we're looking at. So we have a hash in Redis, and the values, the actual values look like this, token, and then the string of the token is part of the key. So then when we get an authentication request for an API request, we just look up the key in Redis. We look up the key. If it wasn't there, well, that's invalid. That doesn't exist, right? And we just fail the request. If it is there, we're going to expect that the value of the key is a user ID, and we'll look up the user. If it doesn't exist, then the token is also not good. But if it does exist, that means we have a user and they have a valid token, and we're going to return it. They're authenticated. This is going to be fast. Storing tokens in Redis is going to be super fast. So this is the kind of thing you should look at, right? If you're breaking down your app into what can I fix, what can I make faster, think about this, right? What can you store in Redis? What can you store elsewhere out of the database to sort of reduce pressure on the database? All right. Did I wet your whistle for questions? Stick around, ask me some questions. Because I'm employed by Redis Labs, the Redis company, I implore you to check out Redis University. It's totally free. My course that is launching on August 18th, which you can sign up for now, is free as well. It's the Python course. So come on by, check it out. I'm gonna stop sharing now and we will do questions.
Hey, Andrew, thank you so much for that wonderful presentation. I think we went into a lot of depth. We have a few questions here. One is, what about db_index is equal to true when creating indexes? So you can add db_index as an option in a model field, I believe. So how does it compare to the way that you've created indexes?
Yeah, you can do that, and that's totally valid. You also have more control through some of these other approaches, right? So you can create indexes using SQL if you want, using a run SQL operation by creating a manual migration. So it's just about control, knowing how all these different tools, what tools are available, lets you sort of tune and pass in more things. Like I would have to look it up because I actually don't remember. But I can imagine if you recall when we were looking at how to create a partial index, you want to be able to pass in a condition value and a queue object to specify what should go in the index. So I don't know that you get that kind of control from that parameter to look at. But okay, did I answer the question?
I think so. I think so.
Okay.
Personally, I create a lot of materialized views myself because I kind of feel like they solve a lot of my problems, but maybe I'm just
Yes.
leaning on one crutch too much. But this is a question from me, actually. What are some issues associated with materialized views? Is it just that you can't really control them very well from the Django ORM, or are there other issues with them?
Um, I mean, for what they do, I mean, they do what they say they do, right? I mean, they're not, I wouldn't say there's anything fundamentally challenging about them that's broken in Django. I mean, as you can see, you can wrap a materialized view in a model.
Mm-hmm.
So you know, you get to read from a materialized view that way. Um, and you know, there's some complexity there, right? Because we have to run that refresh query, figuring out when and how to do that.
Mm-hmm.
Um, Figuring out when and how to refresh a materialized view just puts you into the uncanny valley of, you know, cache expiry. So there's a big, you know, it's like there's a joke about like unsolved computer science problems. So figuring out when and how to expire cache is a major problem just by itself. But you're going to have that problem no matter
Absolutely.
where you store data like that, right? So you know, I wouldn't say there's a big problem using materialized views. I think they're really cool.
Awesome. So we have a really interesting question here, and maybe this is more of an subjective question rather than an objective one. But when is it better to use raw queries rather than the ORM?
Yeah, so it is a subjective question. Although you might think it's subjective, I'm not sure. But you know, if you got a gander at that subquery that we looked at when we looked at annotations, right? So if you just browse the Django docs on annotations, you'll see a number of relatively simple looking annotation queries. There are a number of functions you can use like min and average and stuff. And when you look at the docs, it looks pretty simple. Reality for some of that stuff gets pretty hairy, you know, when you're in the field. And as you can see, like as soon as we started like having to do advanced stuff, the code to do that, if you're not familiar with advanced ORM stuff in Django, the code to do it can get kind of confusing, or you might, you know, not everybody on the team is going to be able to look at it and be like, oh yeah, totally, subquery, got it, you know. So the trade-off there is as you build more complex queries, sometimes the code that you have to do, you have to use the ORM to do that becomes really unwieldy. So
Mm-hmm.
you know, I personally, some people don't like SQL and they don't want to see it in the project. I'm not one of those people, and I think sometimes you just have to use SQL. Like there's just some stuff, even in my, if you look at the example code for my book, I think when we did key set pagination, I had to use SQL for some of that because there's just some stuff that, like, man, this would just be so simple in SQL. Well, why not just drop the SQL? I mean, that's, you know, so I think
Yes.
sometimes it's just so complex that you just have to use SQL.
All right. So there's this other question that I think is quite interesting. This person is using Django 1.8 for production. What are your tips to upgrade from Django 1.8 to the latest version?
Ooh, that's a good question. That sounds like a good blog post. Yeah, you know, my tip is just to take it slow. You know, I started thinking about migrations I've done in the past. Um, yeah, we migrations always take time, and even if it's just from, you know, one version to the next, it can sometimes take a lot of time. So I would just start working on it, start working on it in a branch. Don't stop the world, stop all your other work, but just try to start making some progress. I don't have any concrete tips like do this one thing and it'll make your migration story like way easier. But I'm going to look into that and I will write an epic blog post about that if there happens to be like one or two things. So I wish I had better advice.
Oh, that's awesome. We can look forward to that. And
Yes.
this question is really about Redis. Uh, is there, how does the performance of Redis compare to something like Memcached? And I'm just asking you this for fun.
Yeah. Um, It depends. I mean, I have to look at some raw numbers and I don't have them. But if you're doing, you know, if you're doing some operations like looking up a key in a hash or getting an item from a set. Those are O of n, they're constant time operations in Redis. So I don't remember, I don't know exactly how fast some of those things are in Memcache, but they're fast, right? They're super fast in Redis. Yeah. Redis writes data to disk if you turn on persistence. So depending on the settings that you choose for persistence, that can add some, that can slow down writes, right? Memcache isn't going to save anything to disk. So you have a lot of control over that with Redis. So you have a lot of knobs to turn as far as the speed you want to get out of writes, and how much risk you can take that the last thing you wrote, that Redis wrote to disk, failed for some reason or whatever, or like say Redis crashed, depending on how fast you want writes to be, and therefore how slow, or the distance of time between each write to disk. Sometimes you might lose some data, right? But it's up to you. You can lose no data. I mean, you probably can lose data, but right, you can tune it so that writes are slower, and you have less risk that you'll lose data. But
absolutely.
I don't know,
so
to answer your question, it depends. It depends on what you want to get.
It depends. For me, I've used Redis in the past. I've used Memcache before, and what I really like about Redis is that control. So you can ask for persistence when you want it, and that's, I think, quite useful.
Yeah, and I mean, just not to like take too much time with Redis, but like it's almost like asking, what's faster, Memcache or Postgres, right? Because Redis isn't just available like to do things that Memcache can do so much more. I mean, you could do streaming, it can do all these different data structures. So, there's a lot there, I think. All right, I won't talk more about that.
And lastly, this is the last question. When to use transactions, and how can we avoid atomic deadlock?
Yeah, so I mean, so you use transactions to ensure that, if you're looking at some data and using it in, let's say, a calculation, that it doesn't change, right, while you're looking at it. And there are just times when you need to use transactions for that. Like there's just no way to get around that fact. It's kind of like physics, right? It's like, well, I mean, I have to write this data, and I can't be using out of date data, so I need to use it in a transaction and make sure nobody else can write. So there's that. There's a pitch to be made for denormalizing your data sometimes, right? So there's denormalizing can make it so that you're writing somewhere else, but there's no free lunch, right? It's like you need to stitch that back together later if you're writing it to a different data store. So and fundamentally, once you're talking about a distributed system with multiple databases scattered around APIs, transactions aren't even really that doable anyway. Like you're not going to even be able to do the kind of transactions you can do with a single database server. So anyway, yeah. What you can do is, a lot of the problems I see are actually migration problems. Like some of the biggest blocks that I've seen in production setups is you did a migration, a null equals true migration or something along those lines, and it just blocks the server for an hour or something, just totally terrible. So you got to really pay attention to some of that stuff, the migration story too. Not really what you asked, but it just reminded me. Okay.
Yes, absolutely. Well, thank you very much, Andrew, for this wonderful webinar. I've learned a lot myself. We've gone into so much depth, and apparently in your book, you go even into further depth, don't you?
Yes, I do.
So, folks, please take a look at the Temple of Django database performance. Apart from the content itself, it's got some really nice pictures in it as well. So you go on an adventure and you basically try to optimize your database, which is really cool. And also Andrew's course on Redis for Python developers that gives you a firsthand account of how to really leverage the best of Redis with Python. So thank you for joining us, and we'll see you again soon. Bye.
Thank you.
Bye, Andrew.
Bye.